Hello and welcome to this webinar regarding carrier aggregation. My name is Zlatko. I'm a telecommunication engineer working within mobile testing for almost 10 years. For this presentation, I will be covering the basics of carrier aggregation. So let's kick off. So a small introduction regarding carrier aggregation. First of all, carrier aggregation or CA is a LTE advanced feature. It's the most demanding feature within the LTE advanced. LTE CA also supports TDD and FDD supports, which means it supports both time division and frequency division. It was first introduced in release 10 of 3GPP specs. CA is developed and all the feature and settings performance requirements are done by a 3GPP working group called Radio Access Network 4. So what are the advantages of carrier aggregation? First of all, we all know that user data within mobile networks today are skyrocketing and will continue to do that, as we see a lot of new apps and services requires a lot of more data. So what CA will do, it will increase the bandwidth within the network, and this will increase the bit rate and the user data. It is also a technology for reusing spectrum allocations within the network. We all know that today's network, there's a lot of spectrum that are not used in an efficient way. The technology of carrier aggregation is also backward compatible with LTE release 8 network. So that means if you have a release 8 device, it will work within the carrier aggregation network. So let's summarize a little bit about some technical basics when you talk about the CA technology. There is something called a component carrier, or shortened as a CC, or LTE component carrier. Each of these component carrier can be a bandwidth of 1.4, 3, 5, 10, 15 or 20 megahertz. Per specification, you can aggregate 5 component carrier at the same times, which means that you can have an aggregation transmission bandwidth of maximum of 100 megahertz per specification. But the 3GPP RAN working group limits 2 to 3 carrier aggregation at this point, which means you can aggregate up to 40 or 60 megahertz. If you look at the table on the right side here, you can see the IMT advanced requirements for real 4G network, and you have the LTE release 8 specification, and you have the LTE advanced 3GPP release 10 specification. So as you can see, the 3GPP release 8 is not really matching up to all the 4G network requirements. It's lacking in transmission bandwidth, peak data rate, and peak spectral efficiency. If you look at the LTE advanced release 10 network, which carrier aggregation is part of, you can see that it's matching all the 4G network requirements for all the different areas. When you talk about carrier aggregation, there's 3 different aggregation types. The first one is called intra-band contagious carrier aggregation. This was specified in release 10 of 3GPP. This means that you aggregate component carriers with no gap between the component carriers. There is, however, a guard period of 30 kilohertz, which is a normal case. The second one is a intra-band non-contagious aggregation, was realized in release 11 of 3GPP. So the intra-band contagious and intra-band non-contagious are aggregation types when you aggregate within the same frequency band. I forgot to say that. Anyways, the non-contagious one means that you aggregate within the same 3GPP frequency band, but you have gaps between the component carriers. So this one is a more normal scenario use case. And the third one is interband contagious aggregation, realized in release 10 of 3GPP. This means that you aggregate component carriers from different 3GPP frequency bands. So how is carrier-aggregation activated? Carrier-aggregation is only activated in connected mode. That means that device needs to execute a generic access procedure that are defined for LTE release of 8, which means you have to do a cell search selection, SIP aggregation, initial random access, NAS information and security procedures, and all this is done on the PCC, called primary component carrier or primary component cell. Each device has its own PCC, so two different devices have different PCC or P cells. There is something called CCC as well, secondary component carrier or secondary component cell. This is added when you need more bandwidth. This is added using an RC connection reconfiguration signal release message. If you want to add this CCC, you use it only for if you need more bandwidth or more user data, and it's also more battery consumption. It drains the battery as well, so when you don't need it, you have to remove it. If you want to switch between different secondary component carriers, you have to do a regular handover. So how does the network know which carrier-aggregation configuration the device has? To check this, you need to do a regular default EPS barrier setup according to 3GPP release 8, and you open up the user equipment UE capability procedure message, and there is an element within this message called RF parameters version 1020. If you open up this one, you have at the end something called carrier-aggregation bandwidth class of release 10 in this case, and this shows that the device supporting A, B, C, D, and E and F class. So let's talk about these different bandwidth classes. According to 3GPP, right now there is 6 different bandwidth classes, 1A, B, C, D, E, and F. E and F is for further studies at this point. So if a device is a bandwidth class of A, it means that it can aggregate a maximum aggregation of 100 resource blocks, which equals 20 megahertz on one component carrier at the same time. If it's a band class B, you can aggregate up to 100 resource block equals 20 megahertz with 2 component carriers at the same time. If your device is a bandwidth class C, you can aggregate up to 200 component carriers, which is equals to 40 megahertz. Then you use 2 different component carriers. If your device is a class D, you can aggregate up to 300 megahertz equals 60 megahertz, and you can aggregate 3 component carrier at the same time. So if you see here below, there's 3 different use cases. The first one is it's a aggregation type of contagious one. CA stands for carrier-aggregation, 1 stands for aggregation in frequency band 1, and C stands for class C. So in this case, you aggregate within the frequency band 1, and you aggregate, you have 2 component carriers because it's a class C. The second use case is a interband non-contagious. We aggregate within the same frequency band, which is 25 in this case, and it's a band class of A, which means you have 2 component carriers within the same frequency bands. The third case, which you can see, is CA_1A_5A. This case is intraband contagious aggregation, which means that you will aggregate with two different 3GPP frequency bands, which is one in frequency band 1 and the second one in frequency band 5. In this case, it's a bandwidth class of A, which means you have one component carrying frequency band 1 and one component carrying frequency band of 5. This table shows a little bit the first defined CA classes for release 10. At that time, it was only 3 of them. You can see here the first one is CA_1C, the second one is CA_40C, and the third one is CA_1A_5A. So one intraband, two intraband, and one interband aggregation. If you go further to release 10, there was added a lot of different combinations. I won't go through all of them. You can go to 3gpp.org and read them yourself. And this table shows the 3GPP run 4 specification tables for different operator combinations. You can see here is some combination for different vendors. AT&T, you have US Cellular, KDD, Vodafone, Rogers, and so forth. And you can see the different bandwidth combination that they have and different classes. On this slide, I'll tell again about the real 4G requirements. The first column, you see the empty requirements for LTE Advanced. The second one is the requirements for LTE Release 8, and the third one is for LTE Advanced. So interesting thing here is to see a little bit about the peak data rates. You see in IMT Advanced requirements is downlink 1 gigabits per second, uplink 1 gigabit per second. If you look at the release 8, it only manages 150 megabits per second using MIMO 2x2 and uplink 50 megabits per second. So if you see at the release 10 and up to 12 LTE Advanced network, which Aggregation is part of, you can see there is downlink speeds of 1.2 gigabits per second using 4x4 MIMO and 0.6 gigabits per second using 2x2 MIMO. And the theoretical part is not that interesting because it's not real live test scenario. And the last slide here shows a little bit about some Aggregation announcement done in South Korea. The first 20 megahertz in 800 and 8.8 megahertz frequency band was implemented with the download speed of 150 megabits per second. In UK launched 40 megahertz Aggregation with the downlink speed of 30 megabits per second. In Australia, Optus was the first one to deploy the TDD version of Aggregation. AT&T announced CA in Chicago for 2 different bands with the bandwidth of 50 megahertz. Sprint or planning for 3 different LTE bands. Today's devices limit the Aggregation of 2 carriers at this point. There is different official devices that support Aggregation, as Samsung S4, Note 3, we have the LG Pro 2, we have the HTC One and M8, iPhone 6 and 6 Plus. So thank you very much for listening. There was a small introduction regarding the Aggregation technology. So thanks and see you again. Ciao.